A Pelton wheel working under a header of 800 meter develops 15 megawatt running at 600 rpm with an overall efficiency of 85%. The ratio of wheel diameter to jet diameter is 15, coefficient of velocity is given, speed ratio is given, determine the rate of flow, diameter of the wheel and the number of jets. So first write down what are the data given in the problem. So given data is head h is equal to 800 meter, P is equal to 15 megawatt and running at speed is given, so N is equal to 600 rpm and overall efficiency eta O is equal to 85%, CV is given and speed ratio KU is given, and they have given one ratio of wheel diameter to jet diameter is given. So capital D divided by small d. Here capital D is wheel diameter and small d is diameter of jet. So capital D divided by small d is equal to 50. They have given. What we have to find is rate of flow, that is Q, diameter of wheel capital D and number of jets, that is small n. It's not capital N, it is a small n. So what is the formula for finding the discharge? What is the formula for finding the discharge? We know eta O is equal to, that is overall efficiency is equal to output power divided by input power. Output power is given in the problem 15 megawatts. Eta O is also given, that is 85%. And what about input power? Input power is nothing but rho g q into h. In that q is the unknown value. So P is equal to, that's why the formula is P is equal to rho g, that is gamma, q, h into eta O. We all understood? By substituting the value of power value rho g, h and eta O, you will get what is q. We all understood? Next one is diameter of the wheel. For finding the diameter of the wheel, U, we know the formula, U is equal to pi dn by 60. Here diameter is unknown, speed is given and U is also unknown value. But we can find U with the help of KU. What is KU? Speed ratio. So U is equal to KU into root of 2GH. Okay. And then next one is we have to find the number of jets. So number of jet is, if we know the discharge and area of one jet, you can find out what is the number of jets used for the turbine. So now we have written what are the formulas required and we can go for the solution. So U is equal to pi dn by 60. In that first we have to find what is the value of U. So U is equal to KU into root of 2GH. Substituting the value of KU and H, you can find out what is U. After finding U, substitute in the formula U is equal to pi dn by 60, you can find out what is the diameter. So finally we got the answer is capital D is equal to 1.835 meter. The next one is P is equal to rho g q into h into eta O. In that substitute the value of power, substitute the value of rho g, substitute the value of h and substitute the value of eta O. You can find out what is Q value. They have given capital D divided by small d is equal to 50. Already we found out what is the wheel diameter, so that you can find out what is the diameter of the jet, that is small d we have found out. From that you can easily find out what is the area of the jet by using the formula pi by 4 d squared. The next is we have to find what is the number of jets required. How can we find the number of jets required? By using the formula total area required divided by area of the jet. We have found out what is the area of the jet by using the formula pi by 4 small d the whole power 2. But we don't know what is the total area required. How to find the total area required? Is equal to discharge, that is the rate of flow divided by velocity. We know the formula Q is equal to area into velocity. So discharge divided by the velocity will give you what is the area required. but we don't know what is the velocity. So how to find the velocity? V is equal to they have given coefficient of velocity is given. So CV into root of 2gh. By using the formula CV, coefficient of velocity into root of 2gh, we can find out what is V1. So total area required is equal to discharge, that already we found out. Q divided by V will give you what is the total area required. So now we can find out easily the number of jets. Number of jets is equal to total area divided by area of the jet will give you the value as 1.58. We can round it to 2 jets. So finally you have to write down the result. What is the discharge, what is the diameter, and what is the number of jets required. A jet of water having a velocity of 40 meter per second strikes a curved vane which is moving with a velocity of 20 meter per second. The jet makes an angle of 30 degree with the direction of motion of vane at inlet and leaves at an angle of 90 degree to the direction of motion of vane at outlet. Determine the vane angles at inlet and outlet so that the water enters and leaves the vane without shock. Okay. Now we have to write the given data. What is the given data? A jet having a velocity of 40 meter per second. So the water which is coming out from the jet is having the velocity of 40 meter per second. So you have to represent it as V1. So V1 is equal to 40 meter per second. Where it is striking? It is striking a vane. It is a curved vane, and the curved vane is also moving with a velocity of 20 meter per second. It is given in the problem. So you have to represent it as U is equal to 20 meter per second. Clear? The next is the jet makes an angle of 30 degree. It is striking the vane at an angle of 30 degree. So it is an inlet angle. So alpha is equal to 30 degree. And they have given with the direction of motion at inlet and leaves at an angle of 90 degree to the direction of motion of vane at the outlet. So it is leaving the vane at 90 degree to the outlet. So beta is equal to 90 degree. Clear? So given data is V1 is equal to 40 meter per second, U is equal to 20 meter per second, alpha is equal to 30 degree, and beta is equal to 90 degree. What you have to find? What we have to find? We have to find the vane angle at inlet and outlet. So that is theta and phi. So how to solve this problem? For that we have to draw the velocity triangle. What is the velocity triangle? You have to draw the curve vane and the inlet velocity triangle and outlet velocity triangle. So see the diagram. There is a curved vane and the water striking the vane at alpha. So V1 and alpha is represented, and the vane is also moving. It is represented as U1. So you'll get a VR1, that is a relative velocity VR1. It makes an angle of theta, that is the vane angle. V1's vertical component is VF1 and V1's horizontal component is VW1. So these are all represented in the, you have to represent it in inlet velocity triangle. And in the outlet velocity triangle, they have given the water is leaving at the outlet at 90 degree. So beta is 90 degree. So you have to draw a straight line which is perpendicular to the curved vane. So that is V2. The vane is also moving. So it is U2, it is represented. We will get what is VR2. That is a relative velocity. It makes an angle of phi. So here we are in need to find out what is the vane angle theta and phi. Okay. Here the horizontal component VW2 becomes 0 because beta is equal to 90 degree. And VF2, that is the vertical component of V2, will be equal to V2. V2 is equal to VF2. VW2 will become 0 in this case because beta is equal to 90 degree. So by by observing this velocity triangle, you can write down the formula for the vane angle theta and phi. Clear? So here, what is the formula for finding the vane angle phi? Tan theta is equal to Vf1 divided by Vw1 minus u1. Here, what are the unknown values? Vw1 is unknown value, Vf1 is unknown value. First, we have to find out that. How to find out Vw1? That is the horizontal component of V1. That is V1 cos alpha. What is Vf1? Vf1 is the vertical component of V1. That is V1 sin alpha. We know they have given the value of V1 and alpha is given. So you can find out the value for Vw1 and Vf1. Clear? So after finding out the value for Vw1 and Vf1, substituting tan theta formula, you can find out what is theta. Okay. Now we are in need to find out the vane angle at the outlet. So what is the formula for that cos? What is the formula for finding the phi value? Cos phi is equal to u2 divided by Vr2. Here Vr2 is unknown value. How to find the Vr2 value? For that, they have given one hint in the problem. What is that hint? Jet leaves without shock. What does that mean? We can take Vr1 is equal to Vr2. That is, whatever the value we are getting for Vr1, you can take the same value for Vr2. Okay. So we are need to find out what is Vr1. That we can find out easily by using the inlet velocity triangle. So from the inlet velocity triangle, sin theta is equal to Vf1 divided by Vr1. Here theta is 53.79 degree. Vf1 is given, so you can easily find out what is Vr1. Clear? So you can take the same value to Vr2. So Vr2 is equal to 24.78 meter per second. We got it. The next step is you have to find out what is phi value. So cos phi, that you can take it, you have written by using the outlet velocity triangle. So cos phi is equal to u divided by Vr2. That is u2 divided by Vr2. So 20 divided by 24.78, you will get what is phi value. The final is, you have to write down the result. Result is vane angle at inlet theta is equal to 53.79 degree and at outlet, that is phi is equal to 36.18 degree. Clear? The next problem is, a Francis turbine is running at 400 rpm when head available is 60 meter. The inner and outer diameters are 50 cm and 100 cm. The constant velocity of flow through the runner is 10 meter per second and eta h, that is hydraulic efficiency, is 80%. Determine the inner and outer runner blade angles. Okay, first we have to write the given data. What is the turbine? The turbine is a Francis turbine. Francis turbine means radial at the outlet. Okay, radial at the outlet. That is beta is equal to 90 degree. You have to keep this in your mind. Okay, and 400 rpm is nothing but capital N. Head h is equal to 60 meter. Inner and outer diameters are given. It is in centimeter. You have to convert into meter. So d1 is equal to 100 centimeter, that is 1 meter. d2 is equal to 50 centimeter. Velocity of flow is constant, that is given as 10 meter per second. Eta h is equal to 80%. What we have to find? We have to find the blade angles. Blade angle is nothing but theta at inlet and phi is the outlet. We have to write the formula. So tan theta is equal to Vf1 divided by Vw1 minus u1. Tan phi is equal to Vf2 divided by u2. The same formula which we used in the last problem itself. We use the same formula. So first you have to draw the velocity triangle. So it's a curved vane. Water with the velocity v1 is striking the vane, and the vane is also rotating, that is it's moving with the velocity of u1 that you have to represent. The velocity is striking the vane at an angle of alpha. v1's horizontal component is vw1, v1's vertical component is vf1. So as v1 is striking the vane and the vane is also moving, we'll get the relative velocity vr1, and it is making at an angle of phi. So this is the inlet velocity. In the outlet velocity, as it is a Francis turbine, you have to draw beta is equal to 90 degree at the outlet. Okay, that is outlet. At the outlet, it will be a radial discharge at the outlet. So VR2, U2 having an angle of phi, and VF2 is equal to V2, and VW2 is equal to 0 because beta is equal to 90. So this is the velocity triangles. What are the unknown values from the, we can find the unknown values from the formula. What are they? VW1 alone is the unknown value. So Vf1 is given, that is 10 meter per second. And what about U1? U1 is also unknown, U2 is also unknown. So first we have to find what is U1 and U2. How to find U1 and U2? We know the formula, U is equal to pi dn by 60. If it is U1, pi d1 n divided by 60. Substitute the diameter value and we can find out what is U1 and U2. The next step is we have to find the unknown value VW1. How to find VW1? For that only they have given hydraulic efficiency. We know the formula eta h is equal to 1 by gh into U1 VW1. In that VW1 is the only unknown value. So substitute all other remaining values. For here eta h they have given, h is given, U1 also you have to substitute and find out the answer. VW1 is equal to 22.5 meter per second. So after that substitute in our formula. For the inlet, tan theta is equal to Vf1 divided by Vw1 minus U1, and we got the answer theta is equal to 81.2 degree. For the outlet, tan phi is equal to Vf2 divided by U2. So you will get the answer phi is equal to 43.71. What is the next step? Write down the result. Result is blade angle at outlet and blade angle at inlet. Okay. The impeller of a centrifugal pump has an external diameter of 300 mm and internal diameter of 150 mm, and it runs at 1200 rpm. The vanes at exit are set back at an angle of 30 degree. If the velocity of flow is constant at 2 meter per second, determine the blade angle at inlet, velocity and direction of water at outlet, and the head developed if manometric efficiency is 0.85. So first what we have to do, we have to write the given data. What are the data given in the problem? External diameter. So how you have to denote it? D2 is equal to 300 mm. You have to convert into meter. And internal diameter D1 is equal to 150 mm, 0.15 meter. And it is running at some speed. That is n is equal to 1200 rpm. And the vanes are set back at an angle of 30 degree. What is that? It is a phi value. Phi value is equal to 30 degree. And the velocity of flow is constant. So Vf1 is equal to Vf2 is equal to 2 meter per second. Okay. And manometric efficiency is given, that is eta m is equal to 0.85. So these are the data given in the problem. What we have to find? We have to find the blade angle at the inlet. Blade angle at the inlet is theta. Velocity and direction of water at the outlet. Velocity of water at the outlet representation is V2. And the direction is nothing but you have to find the angle. What is the angle? Beta. And the head developed. What is the head developed? How to denote that? H. So what are the things we have to find for this problem? Theta, V2, beta and H. Okay. For finding the values, what we have to do? First, we have to draw the velocity triangle. It's so simple. What we drawn in Francis turbine, just reverse that. The reverse of Francis turbine is the velocity triangle for the centrifugal pump. Clear? What we drawn in Francis turbine? Outlet will be radial. That is beta is equal to 90 degree. VW2 is equal to 0. V2 is equal to VF2. But in the case of centrifugal pump, inlet, you have to consider that as an inlet. Like alpha is equal to 90. V1 is equal to VF1. VW1 is equal to 0. Clear? Whatever the things which is in the outlet in the Francis turbine, the same thing, but you have to change the notations. In Francis turbine, it will be all will be 2, but in the case of centrifugal pump, you have to write it as 1, 1, 1. Change the notation. What is that is? In Francis turbine, radial discharge will be at the outlet, but in the case of centrifugal pump, radial discharge at the inlet. Clear? So, you have to draw the velocity triangle. Clear? So, first we have to find the angle that is a blade angle at the inlet. How to find the blade angle at the inlet? So, tan theta is equal to, from the triangle, VF1 divided by U1. Blade angle at the inlet, VF1 divided by U1. Here, VF1 is given in the problem, but we don't know what is U1. How to find U1? But we know the formula U1 is equal to pi D1 n divided by 60. So, substitute the value of D1 and n, you will get the answer what is U1. So, substitute the value in tan theta and we can find out what is theta. That is the blade angle at the inlet. What is our second aim? We have to find the head. How to find head? For that only they have given manometric efficiency. So, what is the manometric efficiency? Eta m is equal to Gm divided by U2 into VW2. The same formula we used in the Francis turbine, but GH will be in the denominator, U2 U1 VW1 will be in the numerator. Here U2 VW2. So, here VW2 is unknown and also H is also unknown. So, we have to find what is VW2. VW2. What is the value of VW2? How to find out VW2? For that, see the outlet velocity triangle. From the outlet velocity triangle, tan phi is equal to VF2 divided by U2 minus VW2. VF2 is given value, U2 is also we can find out by using the formula U2 is equal to pi D2n divided by 60. From that we can find out what is VW2. Clear? After finding the VW2 value, substitute in eta m formula and we can find out what is the head developed. And the last thing, we have to find what is the velocity of water at the outlet. How to find the velocity of water at the outlet? For that also look into the outlet velocity triangle. It will be in right angle triangle. So, right angle triangle, here VW2 is known value, VF2 is also known value. So, easily we can find out what is V2 by using Pythagoras theorem. So, after that we have to find the direction. So, tan beta is equal to VF2 divided by VW2. So, substitute the value of VF2 and VW2, we will get what is beta value. So, our answer is beta is equal to 7.4 degree. Finally, you have to write the result. Blade angle at the inlet theta is equal to, velocity of water at the exit is equal to, and the direction beta is equal to, and the head developed is equal to. Okay, clear?